Hello, let's do PC FRQ 2014 number 2. So, it's a polar question, and let's start with part A, which is computing the area of the shaded region in the graph. So the first thing we do is divide the graph into two sections. One where we would use the area formula on r equals 3 graph, and one where we use the area formula on r equals 3 minus 2 sine 2 theta graph. Okay, so now we just compute this area using the formula. So for the first area, let's say the quarter circle, and this is just 1/4 times pi r squared, where r equals 3, so 9 pi over 4. Okay, and then the second part, we have 3 minus 2 sine 2 theta, and it's going from 0 to pi over 2, so take the integral from 0 to pi over 2 of 1/2 times r squared, which is 3 minus 2 sine 2 theta squared d theta. And okay, how do we evaluate this? Well, we have our TI-86 here, and how we evaluate this is first go to CALC, second divide, and then pick F5, which is F and int. So the first parameter is plugging in the function, which would be half times r, which is 3 minus 2 sine of 2. I don't see a theta on this, so we can just use x. 2 sine 2x, and then square that. And now we do a comma, and we say, okay, it's dx. And then now we enter the lower and upper bounds, which is 0 and pi over 2. Hit enter. And we get 2.63. Okay, we got 2.639. So now we just add this to 9 pi over 4. And that should give us the answer of 9.707. So 9.707. Or if you use rounding, 9.708. We don't have to use units here, so we're done. Okay, now we can move on to part B. What is part B asking for? Dx d theta. Now, what is x? X is always r times cosine of theta in polar. And since we know r in terms of theta, r is a function of theta, we have 3 minus 2 sine 2 theta times cosine theta. This is x, and we want to find dx d theta at theta equals pi over 6. Okay, we can plug this into our calculator. So we go to second divide, which is calculus, and then numerical derivative. Now we enter our function, which would be 3 minus 2 times the sine of 2, let's say, y. And then multiply this by cosine of y. Then our variable here was y, and we want to evaluate this at pi over 6. So we plug this in, and it should return the, oops, let us fix this syntax error. Where was it? It's because we forgot a parenthesis here. So we can just put that in and hit enter. Okay, we get negative 2.366, and that's our answer. Okay, so now we can move on to part C. And part C is asking about the distance between the two curves from 0 to pi over 2 and the rate of the distance of change with respect to theta at theta equals pi over 3. Okay, how do we do this? We first find the formula for distance. Distance is referring to the difference in radii, and between 0 and pi over 2, r equals 3 is bigger than r equals 3 minus 2 sine 2 theta, so the distance is just 3 minus 2 sine 2 theta, which is just 2 sine 2 theta. Okay, and we want to calculate d theta at theta equals pi over 3. Well, we can actually do this without a calculator, because 2 sine 2 theta is really easy to differentiate. It's just 4 times the cosine of 2 theta. And from here, we plug in theta equals pi over 3. It's 4 cosine of 2 pi over 3, which is just 4 times negative 1/2, which is just negative 2. And that should be our answer, negative 2. Okay, now we move on to part D. So particle is moving along the curve, the weird one, and we have d theta dt equals 3, and we want dr dt at theta equals pi over 6. Okay, so this is because we have like two different derivatives. This is like a huge hint at chain rule. So let's find dr dt in terms of d theta dt. What do we multiply to d theta dt to get dr dt? We multiply it by dr d theta. And what is dr d theta? Okay, that's just right here. We can easily calculate this. Dr, okay, let's do a comma. Dr d theta equals 0 minus 4 cosine of 2 theta, or just minus 4 cosine of 2 theta. Okay, now d theta dt is 3, so let's go back to dr dt equals 3 times dr d theta at pi over 6. Now cosine of 2 times pi over 6 is cosine of pi over 3, which is just 1/2. So negative 4 times that would give us negative 2. And multiplying these we get negative 6. And that should be our answer. Okay, so now the question is, what can we do to do better on polar questions? Well, actually, parametric polar seem to be in similar categories, and there's one really great resource online, Paul's Online Math Notes, and he has a chapter on parametric equation and polar coordinates. And if we look here, it has really detailed notes. They derive everything, and they have sample problems, and they also have practice problems. So this is really good. Specifically for polar coordinates, we have the Cartesian polar coordinates, we have derivations of formulas, we have like tangent lines, goes over the basics, and we have area, which is the how this 1/2 r squared d theta, and we also have arc length, which is there's a really nice formula instead of using the standard formula, and it even goes into the 3D if you want to learn about this 3D stuff. So overall, this resource is probably the best resource besides the textbook for calculus with polar. And that's it.